Hi everyone. Quickly we'll test the sound. If all works, we'll begin in 1 minute. So, time strictly 5 o'clock Riga time. And we will begin our webinar. It was a while since we met in such a format, but I think this release is worth presenting in such a format, and I will explain you why in a while. So I'm going very quickly go through the overview about what major changes were done in TRAFOLO for the last couple of months, what new features you should expect, and what new templates you can use and play with to build your own magnetics. Overall, it should take half an hour max. We'll try to very briefly go through all those 3 steps. So one of questions that users were asking whether we can solve planar magnetics. And our usual typical answer was that yes, you can import planar magnetic geometries and then set up the model and simulate it. But of course, it's very inconvenient. Like you oftentimes use KiCad or Altium or similar tools like for designing your planners, and it would be very inconvenient for you ask you to always export 3D geometries because it's very complex. So with this release, we are introducing a DXF import, which you can extrude and make 3D geometries. In the future, we are going also to support Gerber files and all of those file formats that you usually use with planar magnetics, integrated magnetics. So basically all geometries, all cases that are planar in shape. Another major change in TRAFOLO is we reworked completely the CAD engine. And that means that we scrapped Salome platform, which you can remember was a very large package that you had to download. And now instead we are going to use CadQuery. And thanks to that, thanks to OpenMagnetics, who have also transitioned from FreeCAD to CadQuery, and thanks to their open source license, we were able to take geometries from their database. So all geometries for ferrite cores are sourced from OpenMagnetics. This means that in very near future you will be able to export mass file from OpenMagnetics, import into TRAFOLO natively, run simulations, and basically validate your designs through the simulation. So that was a necessary step, although for some users who have created geometries in previous TRAFOLO version, this will cause some issues with porting old models to the new ones. But don't worry, we will provide some videos explaining how you can port your older models to new ones easier. And if you will have any issues, we will help you with that, resolve you, or just try to mitigate any inconvenience that you will have in this transition process. Another change, you were asking whether there are temperature-dependent core material losses. And the typical answer was no. You had to have separate materials for different temperatures, separate Steinmetz coefficients or core losses. And of course, that was very inconvenient. And so in this release, we have implemented thermal dependence. So we source material data from OpenMagnetics, thermal coefficients and Steinmetz coefficients, and now you can model core losses that are dependent on the temperature. Although now currently only temperature dependence from the temperatures that you initially set, like initial temperature, but in the future we will also extend this to full nonlinear temperature dependence. And speaking about new templates, we were trying to find such examples that correlate with real applications as much as possible. However, most of companies that we are working with, they do not allow us to share their component designs for different reasons. So we have to find a middle way, find some applications that are challenging enough for the FEM software, interesting enough, and at the same time would not require us breaking any NDAs. So one of such applications is wireless power transfer for automotive. So this design is taken from the standard SAE J2954. You can find it yourself, which basically contains different designs for both receiver coil and antenna, for both basically coil setups with also the specs for dimensions. So we took one of those designs and simulated. Later I will demonstrate you how it's implemented in TRAFOLO. Another template that we are quite proud of is, as we call it, vinyl record, although people from another company who have created a physical prototype of such component call it in different mystical names, but we will call it a vinyl for now. So the real name for those components is thin film, and basically the idea is that those are like a future inductors, future transformers used in microelectronics that could allow them work in a very high frequency range very efficiently. And thanks to a very thin core and very high saturation flux, they could be like quite efficient. So there are a few tricks that you need to keep in mind when you are modeling such thin film inductors. I will briefly also cover in the demo what's as we think is a major thing about like modeling them, but let's do that in the demo. And finally, again, like for a long time you were asking whether TRAFOLO can run three-phase transformers like delta star configuration, and our typical answer was that yes, but there were some things that we considered is a bug or an issue in the software. And as it ended up, no, there were no issues. Like for a long time, there were like we were able to model those three-phase transformers. The issue that I thought was that there was a mismatch in winding losses between limbs on each side, but we found out that this is physical. So stay tuned. Soon we will publish an article, Pitfalls in Modeling Magnetics, where we will explain what should you expect when modeling three-phase transformers. Not only about losses, setup, but also about the way how you can mitigate some numerical issues when setting up such geometries and such components. So stay tuned, follow Pitfalls in Modeling Magnetics. And as I promised, we will briefly go through the demo just to demonstrate you what are those new features that you should expect in the newest version of TRAFOLO. And first, I want to demonstrate you import of DXF file for a vinyl inductor. So this is a typical DXF file which will contain information about different layers. In this case, it's 4 layers. Basically top, bottom, pillar, and magnetic part. And the interface is very simple. Once you import it into TRAFOLO, all you have to do is to provide offset for the layer and thickness. So the pillar would start from 0, the thickness would be 3, the bottom start from 0, the thickness would be 1, the top would start from 2 millimeters, the thickness would be 1, and for magnetics we will start from 1.4 and we'll set the thickness 0.2. So this geometry is still 2D. Once I click apply, the magic happens. We get a 3D geometry for the 2D files that we imported. Another very nice thing about TRAFOLO import tab is that you can see there's a new toolbar which will allow you to do different CAD-like operations with your geometry. For example, here I select 3 parts. For the coil, I can go to Boolean, fuse, apply, and now this is one piece of geometry. You don't need to go to external CAD software. You can do everything, basically not everything, but most tasks that you would need usually to do in external CAD software, you can do now in TRAFOLO. And this is like very, very convenient. And as you can see, it's very fluent, very fast, even for very complex geometries. We tested it. So now I will select coil as a coil, core as a core, and that's it. All I need to do is click apply, OK, and my geometry is going to be transferred to the core. Here's the core, and to the coil section. So all what I would need to do is to tell materials, define the winding type. So here, for example, instead of stranded, I would use massive. Go to assembly, assemble. As you can see, as this geometry needs rotation, so now you can either rotate, do rotation here under the coil and core tab, or go back to the import and do this rotation from the import tab. So I selected coil and core, transform, select the axis. In this case, it's Y. So here I just type 180 degrees. Click apply, that's it. Apply, OK. And now if we go to assembly, we should see the geometry is now, it's actually not, but well, it should be. Anyway, so interface for manipulating with CAD geometries, DXF import for 2D geometries. Next is time for a very brief overlook for different geometries. Sorry, for different templates that we will provide you. So first one is wireless power transfer. And the main magic that you should keep in mind is that it will not be sufficient for you to run one simulation. You will need to run a couple of simulations for the geometry. First, to find out what is the self-inductance of each of those coils. Once you find out the self-inductances, then you can calculate the capacitances that you need to match to this resonance circuit. Put capacitances in series or in parallel, depending on the wireless circuit that you are using. There could be both in series and parallel. So in this case, we just for demonstration purpose used the simplest circuit that guarantees the resonance. So put those capacitances in the circuit, and as a result, we get a very beautiful resonance for both coils. Also, as you can see, the magnetic flux, sorry, it's not a magnetic flux is here. So both primary and secondary coils generate enough flux and are coupled good enough so that this receiver coil also receives some flux. If there would be no resonance, you would almost see no magnetic flux in this core section. So very simple, very beautiful template. So now you can start playing with wireless power transfer yourself. Another template that I would like to demonstrate you is integrated magnetic on silicon. So this case is very similar to the component that one large European company is prototyping and building. But it's only a coincidence that this design it looks very similar. Starting from materials, in this case, it's a special core material. As we are solving a frequency sweep, here we selected a constant permeability, but you can also get a BH curve for this material. Geometry is assembled. You solved as a symmetric problem. We advise you not to jump into full geometries, but rather first always solve and try to reduce your problem to a symmetric. You will save a ton of time and effort, and this time and effort could be spent in things that really matter. And the things that really matter for such planar magnetics is, guess what? Mesh. And especially mesh not for windings, but for the core. Because the core has high permeability, and usually those deposited cores are conductive, so the skin depth is much smaller than the skin depth for the winding. So you need to pay attention to the mesh that you are using. If you head to Pitfalls Modeling Magnetics, the latest article, we briefly discuss what could happen wrong if you neglect meshing in the core. And those people who are like big fans of big simulation packages, be aware if your simulation package relies only on tetrahedrons and doesn't have the prisms to resolve boundary mesh layers. Well, be very careful to make sure that you properly resolve those currents that are being generated in the core. We did a study for pure tetrahedrons versus tetrahedrons, but with a boundary mesh layer, and this is like a pure boundary mesh with prisms, which TRAFOLO uses. And as you can see from those results, results look very different. So be careful when modeling such magnetic components. So let's go back. So overall, this simulation, it took about 8 minutes and for 1 point. So if you would need to do a sweep, expect that you would need a few hours, but that's a good overnight run. Very beautiful case, very, I would say, good from the perspective of the future, where magnetics are heading. And the last template that I would like to demonstrate you is oil-immersed three-phase transformer, which is partially based on this article. You can in TRAFOLO like click here on the link, and it will point you to the article. In this article, it's very interesting. Like, I cannot say that it's like fully descriptive about all the needed settings that you would need to replicate this case, but still, at least they provide circuits, dimensions, so it's a very nice and neat article. Anyway, let's load this case and take a look. First thing first, you may ask, what's about the core? Why don't we have laminations for the core? Don't worry, likely in the next release we will add a template for the cores that would have those beautiful boxy shapes. It's not as difficult to include that as a model, but we were in this release focusing mostly on like CAD engine, so didn't have enough time for making the stepped core. But anyway, it will be implemented. What's the difference between a three-phase transformer and any other case? Of course, is circuits. And circuits for this case are rather complex. For those who want to dive deep into this template without waiting for new article Pitfalls modeling magnetics, I could advise you take a look on those resistances that are placed between the primary windings and the ground. Very large resistances, but only for numerical reasons we better put them here. Otherwise, simulation software sometimes is so accurate and at the same time having a machine precision causes convergence issues if you don't add those resistances. So pay attention to that. Other than that, it's a typical delta star configuration, where on the secondary side we add resistors. Of course, if you want to introduce imbalance, all you need to do is just to change those resistances, introduce imbalance, run the simulation, should run smoothly. This is a 20 kilowatt to 400 volt transformer. Also modeling heat transfer in this case. Of course, we're cheating. We are not running a full CFD conjugate heat transfer model, but instead we are filling everything with a bobbin. And for the bobbin, we provide effective material properties. In this case, roughly calculated that heat conductivity, in this case for the thickness of cardboard, which is impregnated with a transformer oil, would be roughly like 2. So, of course, full CFD simulation would be best, but we need to cut corners here and there. But overall, I do expect that the simulation results should be quite accurate if you know what you are doing. So, there are 2 windings, primary and secondary. The primary, which is, I guess, here on the outside, yes, high voltage primary winding on the outside. It is made of a stranded wire, basically 4 wires put together. So obviously this is a homogenization model. Well, and for the secondary winding, for the low voltage side, there's a foil winding. So no surprises here, just go to configure wire, set RAC, RDC, fill factor, and choose it as a foil. As a result, what you should expect this picture, secondary side, which has the most current and foil winding due to skin effect. Basically, the losses are concentrated here on the top on the bottom. If you want, you can open, of course, results in ParaView and see those current distributions more beautifully. The core losses, magnetic flux, very close to around like 1.5, 1.7. This is typically for electrical steel, very uniformly distributed. In the templates that we will provide in the future, we will also include those parasitic gaps here so that you can account for those as well. Many of you likely will ask, so how about anisotropic permeability or anisotropic pH curve? Unfortunately, no. Currently, it's uniform. Like, we do not provide yet for you to ways to set anisotropic permeability or pH curve, but we consider adding it in the future. So if there's interest, let us know. We might think about workarounds, how to allow you to do those simulations, but we would expect that you then help us to validate those models too. So, and last but not least, temperature distribution. So here, because of winding and winding losses in the foil winding and the core losses, the heat is mostly distributed on the inner limbs. So that's pretty much everything. So we covered it in 23 minutes. If you have questions, a couple of minutes. We will wait for any questions that you may have. If no questions, well, then we suggest you to go to TRAFOLO webpage, download the newest version of TRAFOLO, or receive the update, and well, start playing. If you will have any issues with porting older cases to new ones, don't worry, just let us know, we will help you. Here on the top of the TRAFOLO, as you can see, there's going to be a one-click button, the way how you can reach me and TRAFOLO team directly, and usually we can provide you support in real time. So do not hesitate. If you get any issues, ask us. If you are from India, then contact your distributor, Realimate Labs, and yeah, that's it. So no questions so far, or there are questions, but I don't see. Let's see, all messages. I don't see any questions. Okay, if no questions, then I think we should stop here, and let's go and play with new version of TRAFOLO. Thank you everyone for joining, and see you.